So I'm really happy to welcome Jackie to the stage today. As you heard, her book has been an inspiration to us as we've developed some of the content for the exhibition and the festival. And Jackie, I just wanted to just start out our conversation today by asking you to talk a little bit more about yourself and what led you to write this book.
Yes. So I made wildlife films for Oxford Scientific Films, which was explored, and Oxford Scientific Films was wonderful at revealing unseen worlds. So we used high-speed cameras to extend time. We used lock shots and time lapse to compress time, macro lenses and lipstick cameras to get into places where you can't normally see. So fascinated by worlds not seen. And I also worked at the BBC making Horizon documentaries on, paleoanthropology and humans and ancient hominids and NASA going off to Lake Vostok in Antarctica to look for life. So all sorts of, and SARS, I made a film on SARS most recently that's been on my mind. But yes, I suppose, and then I studied zoology, and I've always come to zoology, or my interest really in zoology has been to better understand myself. I think of the animal kingdom as a mirror that we can hold up and better understand what it means to be human.
That's a great metaphor, yeah.
So that was the thesis behind Sentient, and my interest in zoology is looking at animals to explore our own potential.
Mm-hmm. And is that why you chose senses as the kind of theme in which to enter this world?
Yes, so unseen worlds. There was a wonderful quote that I include in the book by Da Vinci, who talks about the fact that we look without seeing, we hear without listening, we touch without feeling, we eat without tasting, we smell without awareness of fragrance. And so our sensory world is so mundane and everyday that by using the animal kingdom, it gives us a little distance and a different perspective on ourselves so that we can get some distance and appreciate what marvels we are and how we sense the world. So that was the thesis.
That's great. Yeah, I mean, in reading the book, it was a very readable experience. And one of the things that jumped out to me personally was that your use of the animals as protagonists in the book. It makes it a very readable kind of journey through the animal kingdom and a way for us to shift our own perspective on how we look into our own senses.
Yeah.
And so I just wanted to also ask about your approach in that way to storytelling and weaving together also very seamlessly the scientific research, which I know is sometimes difficult in storytelling.
Yes,
we do that very well.
So we were talking about when I was at the BBC on Horizon, we were sent on a script writing course by this well-known Hollywood scriptwriter called Robert McKee, which the reason being is I think humans relate to storytelling better than they do to a barrage of facts. And so when I was making documentaries, and always when I've made documentaries, it's been about how to make someone curious about what's going on. And one of the ways one can do that is what I'm interested in when I meet a scientist is, why are you interested in this? What about this makes your heart beat a little faster? How did your discovery process evolve? And so that's that plus these animals which I used to make wildlife films, and so when I set them out at the beginning, they are these creatures in their environments and their habitats being spectacular. So these different storylines weave together and produce, hopefully each chapter is a kind of arc and a story in and of its own.
Yeah, so I hope through this discussion we can actually illuminate some of these stories of it. Maybe we can just start with the first chapter of your book, which left a big impression on us, was what we can learn about our own sense of color vision, for instance, through this creature called the peacock mantis shrimp. Mm-hmm. And I think we have an image.
Oh, there's the book.
Yeah, the book is behind us.
So that's the British cover, and that was the American cover. For some reason, they did a different cover. Yeah.
Can you just talk a little bit about what we can learn from the peacock mantis shrimp about our own sense of vision?
Yes. So I introduced this shrimp with an extraordinary story about its punch. So people tend to know these peacock mantis shrimps through their punch. So they're neither shrimp nor mantis, actually. They're more probably closely related to a little lobster that fits in the palm of your hand, but they have this lethal punch. And in fact, a scientific team in California filmed the punch with the same high-speed photography that I was using at OSF. Well, they started with what they had in the lab, which was 1,000 frames a second, but the shrimp's punch was a motion blur. So they upped it with the help of a BBC documentary film crew that was passing through to 5,000 frames a second. And then they could break it down and realize that this little punch was flying through the water at 50 kilometers per hour. But then they used a 20,000 frames per second. And when the shrimp's punch was seen at that resolution, you could clearly see that when it impacted the shell of its paw prey, there was a spark of light. And that made them realize that this was the most forceful punch in the animal kingdom. And this was a way to build the character of my shrimp into what I think is more special, and those are its eyes. And science has shown that these shrimps have 12 different color photoreceptors in their eyes. Now, to put that into perspective, when we look around this room with an average, unremarkable human eye, see perhaps 1 million, perhaps several million different colors. But the way in which we have 3 photoreceptors, so they produce millions of colors, and these shrimps have 12. So this is why you have people waving their arms around when they try to describe what a shrimp might be seeing, what kind of rainbow a shrimp might see. But the chapter doesn't finish there. There's a little twist. There's a twist in it.
Mm-hmm, mm-hmm. They can do some damage, yeah. And so what can we can learn certainly about ourselves, kind of the limitations, right, of our own color vision. But did you learn that some people are more like these shrimp than others?
Yes.
Yeah.
There are very rare individuals who have 4 cones or 4 color photoreceptors. And there might be someone in this room. The idea being you wouldn't realize you were anything special because what you see is your boring Monday morning when you get out of bed. So the very first chapter starts to explore this notion of, that our perception is a very private experience. And it's very difficult for me to know what anyone in this room is seeing right now, let alone a shrimp, which is where the chapter takes us, because despite these grand claims of these shrimp seeing thermonuclear explosions of color, actually when the scientists tested these shrimps, their color sight wasn't particularly good. So even if we know the kind of hardware behind how an eye works, it's still quite difficult for us to enter the mind, to do what Thomas Nagel said, what's it like to be? Yeah.
Mm-hmm. Great. And another example, so I just wanted to start out with some of the common senses that we all kind of think about on a daily basis, and then some that are a little bit less common. So just quickly talking about hearing, for instance, you dedicate another chapter to the great gray owl.
Yes, this was my bird that I chose. I mean, it was each time it was difficult to kind of narrow in on one animal to talk us through a particular sense. But I chose the great gray owl because it's this splendid bird. It's got a wingspan of 1.5 meters. It's got mottled plumage. It's got bright yellow eyes, and it can hear a mouse from 30 meters away. Even if that mouse is under a mound of snow, it uses its ears to pinpoint exactly where that mouse is, and unfortunately for the mouse, is with deadly precision. So I use this creature to explore our sense of hearing and to unpack what hearing means for us. And there are various aspects of hearing I look at within the chapter, but the one perhaps that I related to or found interesting was this notion that in addition to sounds having volume, having timbre, tone, individual sounds, there's also this notion that we are surrounded by sound space. So I'm feeling a bit discombobulated hearing my voice projected in ways it's not normally projected. And that's because we're rather brilliant at hearing space. And a theme through the book is that I talk to, meet, listen to exceptional humans who have slightly different senses, exceptional senses. And in that particular instance, I'd read a book a long time ago by a man called John Hull called Notes on Blindness. And it's about he started the world with sight, and over time he became what he called deep blind. And there are some incredible paragraphs in this book where he describes this idea of sound space. So he talks about thunder putting a roof over his head. And he talks about loving it when it rains, because suddenly the distance, which is impenetrable normally for him, comes alive, and it's like the rain cloaks the world with a blanket. So this geographical aspect to sound is what the great grey owl is absolutely brilliant at. So I use him to explore this idea within ourselves.
Yeah, and I think in a lot of these different chapters, we also learn how these senses really work cross-modally. So there's, it's very difficult to pick them apart, right, into
Completely.
just one essence of a sense.
Yeah, absolutely.
And so that's a great example, I think, in the owl as well as in the human. And another one that really stuck with us when we were reading your book in the office and discussing it, was the Goliath catfish, and what we can learn about our own sense of taste. And one of the sensory biologists that you quote in your book calls the catfish a swimming tongue, which was a very great way for us to kind of envision what this might be like.
Yes.
So can you talk a little bit about that animal and how that also compares to our own sense of taste?
Yes, this catfish has been very popular for that reason. But just to put that again in perspective, I choose not any old catfish, but the Goliath catfish, starting with Theodore Roosevelt about 100 years ago, and he did this incredible adventure often into the Amazon, looking for the River of Doubt, let's say. And he encounters this vast catfish, and the locals tell him that apparently this fish eats man, and it can get up to the size of 3 meters. So the Goliath catfish is a whopper of a catfish. So if you imagine this swimming tongue, and the idea is that its body is absolutely covered in peppered, or more densely than peppered, with taste buds. The same taste buds that are found on our tongue are on its flanks, on its whiskers and on its flanks. So this idea of our tongue swimming out, becoming enormous, 3 meters long, and swimming through the murky waters of the Amazon, where eyesight isn't particularly useful for this creature. It uses its whiskers, catfish whiskers, to feel its way around, but for longer distance, it tracks prey using taste. So yes, and I use this fish to explore our sense of taste. And I interviewed a chap called Jelle Atomer, who was working at Woods Hole, now retired, but he had studied and gone to the trouble of counting the number of taste buds on a bullhead catfish, which is much smaller. And the bullhead catfish has something like 200,000 taste buds, something like 25 taste buds per square millimeter, so densely packed. And in comparison, our tongue, I mean, it's impossible to come up with numbers, but let's say about between 5 and 10,000, let's say 8,000, not very many. But there is a scientist called Linda Bartoshuk who discovered human supertasters and human supertasters. And these are people who taste the world so acutely. In fact, it's not a pleasurable experience. You don't want to be a supertaster because things don't taste particularly nice. So like the catfish, in a way, our sense of taste is a numbers game. But then the bit I really found fascinating was that there is a revolution occurring in the world of taste at the moment about solitary chemosensory cells. And we think of the taste buds on our tongue. That's what gives us a conscious perception of taste. But what we're discovering is there are taste buds elsewhere. A bit like the catfish, we have them on our body. So we have them in our windpipes, in our nose, we have them in our gut. So these cells taste, but they don't lead to a conscious sense of taste. But they're still working on our behalf, like in the nose and the windpipes. Bitter receptors expel pathogens, they make us sneeze. In the gut, sweet receptors taste when you've just had that nice big piece of chocolate cake and encourage you to eat more. So it's that was a very interesting chapter. It kind of opened my eyes up to taste, because it's beginning to redefine what we mean by taste. Something that a taste cell that doesn't isn't a conscious perception of taste.
So maybe we're a little bit more like walking tongues than
we
thought.
Yeah,
yeah, exactly. And I can remember also from the book other examples: lobsters and seals and butterflies, things that are tasting with fins or legs.
Yes.
And that really stuck with us as well as just a great imagery.
I mean, it's wonderful, isn't it?
Yeah,
the
it's
animal
wonderful,
sensory
yeah.
world is mind-boggling.
So there's another thing in the book, this is a transition to another sense that sometimes is a bit overlooked, where one of the scientists that you refer to in the book was asked, which sense would you least like to lose? Or he brings this up in the book as a common question, right? And more often than not, or I should say the answer is, go ahead.
Well, typically, I mean, it was one of the questions I started asking people at the beginning, because it's just this fascinating. I mean, most people would say they wouldn't like to not be able to see. But this particular scientist who you're referring to, Francis McGlone, who's a touch specialist, neuroscientist, his mother was a nursery school teacher, and she'd asked that question of her children one morning, and one of the children piped up saying, touch. And that stuck with him. Possibly it was part of the reason, who knows, it stuck with him. But I do look at, I look at the idea of not being able to feel something and touch something is almost too difficult to kind of comprehend. And I look at this sense of touch with a couple of animals, because Francis also said that it's probably, of all the senses, the least understood sense of ours. It's the one we always come to last when we're asked to reel off Aristotle's 5. And the research now is showing that although huge amounts of time and energy and research have been dedicated to understand how our fingers feel their way around things, can feel the shape of something, the texture, the size, using Merkel cells in our fingers. There are other sensors within our skin that, and it's a whole other dimension to touch, which is sensors that make us feel something. So in addition to mapping the topography of the world, if we're touched, it's more a sense, different sensors relating to what happens when you're touched. So I use the vampire bat to explore our senses or sense of pain and pleasure. And in fact, the pain chapter starts in Germany at the University of Bonn with the vampire bat, looking at how these extraordinary creatures are able to detect warm temperatures from a distance. And that kind of segues through to modern day, where David Julius, who won the Nobel Prize for Physiology or Medicine last year, and he's been doing incredible research into these sensors called trip receptors, which enable us to feel temperature, but also painful temperature. So he looked at the trip receptors in the vampire bat that Uwe Schmidt at Bonn had studied a few decades ago. So there's a sliding scale of temperature, and it comes with a sliding scale of pain. And then Francis, who we referred to, was looking at another sensor in our skin that essentially fires only when something the same temperature as body warmth with a light pressure rakes across your skin or smoothly moves across your skin at between 3 and 5 centimeters a second. In other words, we can all see what that is, a caress. So our skin is we look up to the night sky and think that you kind of cast your eyes out and wonder what's out there. But actually, a kind of unexplored horizon is our skin. I mean, it's full of wonder, and scientists are beginning to kind of unravel the senses that enable us to feel pleasure, pain.
And would you say that those senses of pleasure, pain, temperature, do those belong categorized within the kind of Aristotle Big Five, or are they kind of manifestations of touch?
So it's a question. It's a philosophical question. It depends on how you define a sense. If you define it according to the sensor, color sight already is 3, or in some people 4 senses.
Right.
So I didn't. I kind of pulled things together. Color sight, colors. It was more through experience. So in my book, I decided to split it in 2. But it's a philosophical, fascinating, but one of those questions that can go round and round depending on definitions, but worth exploring.
Certainly, yeah. And so one of my other favorite juxtapositions in your book is that between the cheetah and the ballet dancer. And oftentimes, a cheetah is looked at in terms of its sense of speed. And that is something that you touch on the book, but you don't really stop there. You keep digging into what it is about the cheetah that really can teach us something about our own sense. And what is that sense? What could a ballet dancer, for instance, learn from a cheetah by watching it run?
So to backtrack to get to that answer of what the sense is, I covered a study that was done in 2013 by Alan Wilson, who's at London's Royal Veterinary Centre, and he was the first person to attach little GPS motion trackers to cheetahs so that we could record all this information of their speeds in the wild while they were going about their day-to-day. He was very funny about this statistic we all quote. You know, cheetahs can run up to 100 kilometers an hour. Apparently, it was done with a Land Rover, a slab of meat, a piece of string, and a stopwatch. So he made it very technical, and he got all the data back. And when he crunched it after months and months of these cheetahs going about their day-to-day, he didn't clock any of those high speeds. I think the highest speeds he recounted these cheetahs were doing were half that. But what he did clock is he clocked the fastest ever accelerations and decelerations for a land animal ever recorded in movement. And this makes perfect sense. These creatures don't just outright chase a gazelle. I mean, a gazelle's evolutionary strategy is to jink or turn really quickly. So what the cheetah has to do, and it's bigger than the gazelle, is turn on a sixpence. And if you've been lucky enough to see these creatures in action, you can see that. And it's that dance. I mean, yes, they're fast, but actually perhaps we should be talking about their agility, like the ballet dancer.
Right, and their sense of balance.
Right. Which is so I use the cheetah to explore our sense of balance. And this is one of those senses that's not in Aristotle's 5,
right.
The ones we parrot from nursery. So the balance wasn't noted by Aristotle, and Oliver Sacks describes these senses in his book, The Man Who Mistook His Wife for a Hat, as secret senses, because they're senses that operate beneath our conscious radar, unless they're lost. And if they're lost, then it's a real issue and a real problem.
I think we're going to have to wrap up soon, but I just wanted to also ask, just sticking with the cheetah for a moment, is it in fact the fastest mammal predator? Are there others that are in fact faster?
So if you
I'm segueing to another animal here.
So in the Guinness Book of Records, an animal that can find, kill and consume its prey faster than a cheetah is apparently the star-nosed mole. And Ken Catania, who studies star-nosed moles, put it in the Guinness Book of Records. He's got the scientific studies to back it up. And if you think of an eye blink being fast, about 300 milliseconds, that creature can gobble up its worms or whatever it is, little tiny prey. We're not talking of gazelles, in half that time. So yes, that's the creature. And that's the creature I use to describe how we feel the world at the end of our fingertips.
And prior to that, scientists were looking to that creature, but to study a different sense, right? They thought it was perhaps smell that was sort of guiding the star-nosed mole, right?
So not particularly the star-nosed mole, but moles. And there was a study done in 1871 in Germany, by Eimer. It was one of the first things I had to do was translate a German paper, Die Schnauze.
Ja, die Schnauze des Maulwurfs als Tastwerkzeug. Yeah.
Yes.
From 1871.
From 1871. So Eimer was one of the first to study the mole's nose and realize that it wasn't a seat of smell so much as touch. And the interesting thing about the star-nosed mole, as opposed to the European mole that Eimer was studying, is that, again, the density of its Merkel cells. So interestingly, Merkel, another German name, contemporary of Eimer, who over in Rostock had discovered the touch cells in our fingers, Merkel cells we now call them, and a Merkel equivalent is on the end of a star-nosed mole. So except for a star-nosed mole, if you think they're tiny, they've got 6 times the sensitivity of the palm of our hand squeezed into their tiny little star, which is about a fingertip. So
yeah, that's another great example, another great protagonist in the book, I would say. So as a last question, which senses would you include, let's say, in addition to the Aristotle Big Five, if you needed to kind of add some of these? Because in the book, of course you talk about balance, but you also talk about time, as a sense, or direction, or even a sense of body, which you use the octopus
to explore the sense of body.
Yeah. So can you just talk about that a little bit as a wrap up?
Yes. So you would. So the sense of body, or more technically known as proprioception, again, is one of those senses like balance that is so automatic and familiar that we don't notice it day to day. And again, if it's lost, then we notice it. And so I was trying to think of an animal that would be best to explore this particular sense. And the octopus, whom I also love and fell in love with watching my octopus teacher. In fact, it's led to a conversation with Craig Foster and myself about octopuses. The book did, which has been brilliant. But they pour themselves through cracks. I mean, they are the animal shapeshifter. So I envisioned that they would have the most exquisite and extraordinary sense of body. It didn't quite turn out the way I thought. And I met a man called Ian Waterman who had lost this sense of body. He'd also lost touch. He's an incredible man. And actually, he was delighted to learn that of all of humanity, he is the man who the octopus has more in common with. ...
And I mean, you also use, as an example of time, for instance, spiders.
So yes, so this is a sense of circadian time, and again I met another gentleman, Russell Foster, who is the most incredible scientist. He started out as a zoologist and is now a sleep and circadian rhythm scientist, who's at the Nuffield running their sleep circadian department, and he's written a book recently called Lifetimes, a brilliant book. But Russell, when he started, had the notion that the eye also had another sensor beyond those that enable us to kind of picture the world. A sensor that was clocking daylight and enabling our circadian sense to clock, to keep in sync with the passing of the day and night. So I could have chosen any animal. I could have chosen a mimosa plant, by the way, because it was de Marion who first recognized that these plants were reacting to night and day, even when they were closeted in a cupboard without any daylight coming in. So body clocks and sense of time.
Mm-hmm. That's great. So speaking of sense of time, I don't know, perhaps we're out of it, but I do invite everybody to take a look at the book, because there's so many other really interesting protagonists, and it does, as Jackie said, really shine a mirror on our own senses of perception. So it's been an eye-opener for me as well.
Thank you, Samara.
Yeah, thank you, Jackie.
Well, thank you for having me.